Good day, folks. Thanks for coming to my presentation introducing signals intelligence, called SIGINT for short. My name is Tristan D'Alvis. Let me get a bit of self-promotion out of the way. I studied at the University of Rochester for biomedical engineering and data science. After graduating, I quickly found myself in the defense sector, starting with L3 Harris, working in the ISR segment. That's intelligence, surveillance, and reconnaissance. And then later on in space systems, developing advanced computer vision solutions to satellite imagery and geospatial intelligence for an intelligence agency. And then most recently, I was a senior data scientist at Booz Allen Hamilton, using my skills in natural language processing and large language models for the intelligence community, as well as helping educate Department of Defense personnel on AI and how they can use it in their programs, and recruit the right talent for their use cases. Now I'm an independent contractor running Auto Solutions LLC, which is a minority-owned small business. So if you're a federal agency or defense contractor looking for my set of skills, I encourage you to reach out to me either on my website, email, commenting on this video, or LinkedIn. Happy to hear from you. Okay, sorry to murder your ears with my gloating. Let's move on to today's topic of SIGINT. The agenda I have is to explain and help you understand what SIGINT is, what are its possibilities and potential future work with examples, because who likes a PowerPoint without images? Great, let's start with defining SIGINT. Signals intelligence, as defined by the National Security Agency, or NSA, is the type of intelligence derived from electronic signals and systems used by foreign targets, such as communication systems, radars, and weapon systems. Now, why do I specifically look to the NSA for this definition? Because they are the leader of signals intelligence at the federal level. We have agencies that specialize in different intelligence types, such as human intelligence, HUMINT, handled by CIA, measurements and signatures int, MASINT by DIA, imagery int, IMINT by NGA, and so on. All these may touch other intelligence types, but they specialize because of the charters at their inception. This is not to be confused by the intelligence community, which encompasses these agencies for sure, but also the departments of Army, Navy, ATF, FBI, Treasury, and so on, all under the Office of the Director of National Intelligence, or ODNI for short. Okay, let's not get carried away by all that right now. I plan on making more educational materials on these intelligence types, specifically GON, but comment what you would like to see. Happy to hear from you. Back to SIGINT. This type of intelligence includes communications and electronic intelligence. COMINT is about intercepting voice, text, or data communications, so think humans trying to communicate with other humans, versus ELINT, which is intercepting signals not used in direct communication, such as radar emissions. So for this, think computer systems connecting to other computer systems. If you're new to SIGINT, you might ask why this int type is so important. Great question. Well, there are numerous threats, whether nation-states, state-funded terrorists, or others that communicate in a variety of ways, thanks to the digital age, and I would say it behooves our defense experts, strategists, military planners to know what they are saying, planning, doing, or not doing to prevent harm to our national interests. It almost insists upon itself. Furthermore, by also continuing our practice, research, and development in SIGINT, it allows us to be more adept at strengthening and protecting our own communications. Essentially, competition will bring out the best in us. Lastly, we need to be able to assimilate with other int sources to produce what we call all-source intelligence. This is the end goal of collection and analysis. Think about what's getting briefed to the President, to Congress, to the Secretary of Defense, and other state officials at the end of the day in order for them to make important decisions of great national importance. They all need all-source intelligence. Now that I've beaten a dead horse, let's get into some more technical aspects. To start, how do we classify what is a signal? Well, to start with base knowledge, it's any form of communication that requires a transceiver, the technical term for a sender, and a receiver, the term for a listener. So examples would be anything using a radio frequency, Wi-Fi, Bluetooth, FM, AM radio, satellite communications, mobile communications, Yes, your phone is a radio. It's a very smart radio. It has an internal antenna and emits signals. It just has a whole bunch of other stuff wrapped around it. These all operate on the electromagnetic spectrum. Shown here in this figure, we can illustrate the wavelengths at which we can see visible light and not see infrared light and other classifications of wavelengths. So satellite, television, radio, you name it. Electromagnetism is the physics of electric and magnetic fields. If you didn't know electricity and magnetism are related, well, let me explain. Magnets produce a magnetic field, which alter electric currents and vice versa. So in this figure here, we have an electrical current, and that in turn will produce a magnetic field that now can influence a magnetic dipole, which in this case is a compass pointing north and south. There are 4 equations called Maxwell's equations that mathematically explain this phenomena, but that's for another lecture. I don't want to get too math heavy here. Now that we know what is a signal, how do we collect it? For our purposes of defense and intelligence, we break this into 4 areas. Land, air, and sea, shown here, have a variety of platforms. On land, we're all familiar with cell phone towers or dishes that you might see on homes for satellite TV. Also now Starlink for satellite internet. But you've maybe seen pictures of spy sites that have large spheres or domes near them. All of these are some sort of antenna, capturing the energy and waves produced on the spectrum that we just discussed. For air, we have planes and jets. We could be trying to listen for other foreign fighter jets, detect radar, or other air surface emissions. A couple of years ago, the big thing was the spy balloon that traversed over the US. Some people wanted to shoot it down with their granddaddy's rifle. Not a great idea. The PRC was probably using it as some sort of collection platform. And of course we have by the sea. There's a famous story of Midway back in World War II. The US intercepted Japanese naval communication. And by doing so, they were able to counter ambush Japanese vessels that were waiting for them at Midway, at the Battle of Midway. So this was a significant achievement, all thanks to signals intelligence and cryptography. I mentioned there are 4 areas, but I've only listed 3. Can you guess the 4th? It's basically where any Hollywood movie goes if you're in the 10th sequel. That's right, space. Since the space race in the 60s, several nations are now heavily invested in space exploration and putting a great deal of systems that orbit the Earth for commercial reasons, but also militarily. Certainly, a big one you can imagine is communication. In the 90s, tracking Osama bin Laden and Taliban leadership, their movements or plans, was done largely by satellite phone communication. So Osama was communicating with his leadership via satellite phone. We were able to determine which satellite phone that is, and every time he would pick up the phone, we would be able to detect him, listen to him, know where he is. All right, moving on. Once we have intercepted some signals, what do we do with it? Well, we analyze it, of course. Yes, because who can do analysis? You can, I can, Army signal analysts, Navy cryptographers, Air Force electronic warfare technicians, RF engineers, computer engineers, you name it. It's gotten a lot simpler these days with off-the-shelf products, and the federal government has put a lot of resources into funding these developments, so there is a large industry afloat because of this need. What can we do with analysis? Well, depending on your use case, we can locate the transmitter, or at least a general direction and distance. We can determine who is transmitting, perhaps who is the intended receiver in some cases, or even track what is transmitting, because most things have a unique signature due to manufacturing inconsistencies. We may even want to conduct a man-in-the-middle attack, which is where we intercept a message and transmit a false message to the intended receiver instead. That can have a lot of negative consequences to an adversary, or simply to overload and block that channel, making it impossible for our adversary to use that communication method. Various use cases. When and where do we do analysis? Anytime, anywhere. The electromagnetic spectrum is omnipresent. Though these waves that are carrying data radiate everywhere. It is entirely difficult to transmit in secret. There are tools designed to continually listen to bandwidths of frequencies and detect changes. So if we know a known frequency that an adversary is using, we can just sit there and monitor it, record it, analyze it for later. Now, of course, you can encrypt this data, but nonetheless, when you send a signal, anyone can still detect the signal that you are radiating, that you are propagating. Okay, how can we do analysis? Well, it's very inexpensive now. For less than $50, you can pick up software-defined radio, antenna, and free computer software tools. The SDRs are cheap devices that visualize the spectrum around you, so you can see the energy and waveforms around you essentially on a given frequency or frequencies. If you don't want to spend any money, people post live feeds of spectrum around them online or specific radio frequencies online, so you can just use their collection data. And then you can use those computer programs to analyze what you're listening, for speech detection or etc. In conclusion, the EM spectrum has endless possibilities, and being able to understand what is operating on the spectrum is the driving force of signals intelligence. It's pretty much here to stay until some physicist researcher invents a new form of communication that does not produce a signal of any sort. Maybe telepathy, but even then the science fiction isn't all worked out, so I don't see that in the near future. At least don't count on it. I appreciate you listening. Let me know if you have questions. If you have a need for a computer scientist, software engineer, data scientist, happy to discuss. Reach out to me. I am available. Cheers, guys. Have a great rest of your day.